Hello, everyone. This is Rick. Today we have a really exciting presentation by my good friend Abhijeth Dugginapeddi. He has agreed to this fantastic presentation about threat modeling. I believe threat modeling is one of those topics that is widely disregarded and there is not enough content to be able to do a good job of it. Abhi, in my opinion, is a master of it and has been doing it for many years, and we are very thankful for him agreeing to do this. So without any more ado, I'll pass on to Abhi. Thank you very much and welcome.
Thanks, Rick. Thanks for welcoming me. And thanks to all the organizers for setting this up and starting it. Hello, everyone. I'm going to start sharing my screen. Maybe one of you can say yes when you can see my screen.
Yep.
Are you guys able to see my first slide?
Yep.
Okay, that sounds good. Thanks, everyone. Hello, and once again, welcome. For those in Australia, good evening. For people outside of Australia, good morning, afternoon, night. My name is Abhijeth. Today we're going to discuss about threat modeling 101. Uh, Basically, it's a 101 session, but I'll probably tell you why it is +1 towards the end of the session. My name is Abhijeth. You probably would have read my description on the Meetup channel. I head like a small application security team at BigCommerce. I lecture at UNSW, and I also mentor a security orchestration platform called as Tropes. You guys should totally check it out, by the way. I've been lucky enough to speak at a lot of conferences, and I've found some vulnerabilities. It's been a while since I've done bug bounties. It's been about 2 years since I found something really cool. But otherwise, I've been an active bug bounty hunter for about more than 5 years. Just like you all, I like cybersecurity. Don't see it as a day-to-day job, but I'm just privileged and feel happy that it's my passion that's converted into my profession. So, welcome. Um, a quick disclaimer, nobody is responsible for whatever I speak. What I mean to say is all the opinions and all the thoughts and all the learnings that I'm going to share in today's presentation are purely my own. Some of them have been referred from few articles and blogs across the internet. I do have links to most of the articles where I've taken screenshots from, so that'll give you guys an opportunity to go to those articles and spend more time and read about them after the session is over. So a quick security lingo in terms of like what are we going to do today? In the next 40 to 45 minutes, we will try to understand some fundamentals of threat modeling, how it works, why you should be doing threat modeling. We'll be running through a sample non-technical case study. The reason I call it a non-technical case study is we also want this talk to be available for non-security engineers or people who are new to cybersecurity. I will tell you the reason why. And then we'll go through a simple sample case, technical case study. And unfortunately, because it's just for 45 minutes, we won't have time for data flow diagrams or running one of the threat modeling tools, but I do have links for it. And that'll give you an opportunity to go home and read about what are the various tools that are available. So when I was a kid, one of the first websites that I accessed on the internet was actually Yahoo Messenger. And when I was a kid, when I was accessing the websites, I think the web architecture back then was pretty simple. It was front end, there was a back end, and anything that you did, the back end would retrieve information and it would display on the front end. As I started growing up, I think the web architectures developed a bit more, and then it became what we call it as a three-tier architecture. There's a presentation layer, and there's some application logic, and there's some database which is serving you a bunch of information that you're seeing on your website. Right now, this is an example of a slightly modernish web architecture, where you have a browser where if you type www.google.com, there's a bunch of actions happening. There's DNS, there's load balancer, there's CDN. And if you're a security savvy company, you're probably having WAF there. There's multiple web application servers. There's a database, there's caching service. There are multiple jobs, queues, services that are running. I saw this tweet on the internet the other day, which I think is pretty legit. Like by 2025, if you ask me how a web architecture is going to look like, this is probably how it's going to look like. It's going to get more complex. There's going to be more microservices. There are going to be multiple small bits and pieces that's going to start talking to each other and interacting with each other. I think we will get really close to something like this as we go forward, not just with web, but just with how computer works, which means complex architecture means complex problems. And one of the most important fundamentals that I have always believed in security or to start cybersecurity is security is everyone's responsibility, right? When I say security is everyone's responsibility, what I mean to say is when it comes to designing such complex architectures or architectures that are not very simple, it is important for everyone who is working on this architecture or working on any design to think about all the problems. Now, the more complex the architecture is, there are more chances of a problem, right? Let's go back. Remember I told you about the web architecture? Back in the day, if you wanted to hack a website, you could go on the internet and type for how to hack a website, and it would give you this magic SQL injection string. And if you put that on most of user inputs, it's believed that half of the internet would be vulnerable to it. Again, when I was a teenager, it wasn't that easy. And then OWASP was introduced. OWASP does an absolutely amazing job in introducing and teaching us about various web-related vulnerabilities and teaching us about multiple vulnerabilities that can help you to attack a website. Now, how hackers actually hack is not necessarily using straightforward attacks, but they are trying to find that one little sweet spot that is exposed on the internet or one little piece of architecture that doesn't have any security or that doesn't have any kind of threat modeling done. And using that, hackers are trying to exploit vulnerabilities and trying to uh, expose companies. What I mean to say, if you remember the modernish architecture uh, diagram, at every individual or like at every individual stage, there are different types of attacks. For example, if you're talking about DNS, you have like DNS brute forcing, and then you could do DNS hijacking, you can do subdomain takeover. If you're talking about browsers, there are so many browser related attacks. If you're talking about database, there are so many database related attacks, etc. The reason it is important for us to understand this is depending on how your company's architecture is designed and depending on how the apps are working, you need to understand that all these assets, you need to try to identify as many threats as possible on all these assets so that you reduce the risk. Asset, risk, threat. Sorry, I'm using a lot of keywords there. So what I'll do is let's try to understand what SDLC is and where threat modeling fits in. So this is a sample SDLC process, and threat modeling is actually one of those most important phases that fits in your design phase. Now, there are some apps that have not gone through threat modeling or like any architecture or design review and have already been pushed to production. If you're a security engineer or a penetration tester who is testing these apps towards deployment or towards production, it's actually okay to go back and try to see what the threat model is or try to do a threat model of your own, because that will kind of give you a better idea on what are the multiple entry points and how are the different ways that you can attack the web application. Remember I said there are multiple keywords I'm using? Let's have some common understanding of those keywords. An attacker is any user of the application. Quite often, when we talk about attackers, one of the biggest misconceptions that non-security people have is they're assuming an attacker is someone from a, a major country that is trying to hack into your country or like cause political damage, or they're thinking an attacker is from a group of community who's trying to attack your website. That is not true. Any user who can access your website in this case, or any user who can access your asset or system is a potential attacker. Whether they would directly do the attack or whether they would their accounts would be compromised so that someone else will be doing the attack is a different scenario. So when you're doing threat modeling, always try to remember you need to know your attack surface. You need to know who the attacker is. A system or an asset is basically whatever we are trying to protect. It could be a website, it could be a computer, it could be a cloud, it could be a database, it could be a system, or it could be a phone. It could be any asset or a system that you're trying to protect. A vulnerability is a loophole in the system that allows an attacker to hack into the system. A risk is a situation which poses a possible threat. In other words, a risk is something where it's something that will define whether your manager will give you a call on a Sunday evening to ask you to fix a vulnerability, or whether your manager will not give you a call, but there'll be a simple Jira ticket, and then you can work on it whenever you can, whenever you have time. So based on the risk that any kind of vulnerability has on an asset, you basically define how and when you want to fix it. So in other words, the asset that is being exploited by a threat actor using a vulnerability is a risk. I think that one single line, which has multiple keywords, should help us in understanding various keywords and various simple definitions. Now that we have kind of got a picture about what we are going to talk about, and we are on the same page on few of the keywords and few of the definitions, let's take a deep breath and let's go in and try to understand threat modeling. Now, I do have a small disclaimer. Since this is a threat modeling, which is something you do in a design phase, which is more of a scenario where you want to understand architecture, where you want to understand how a system works. I don't have a cool demo, but I do have a case study where I'll try to make this interactive. So in about a few minutes time, I will request you guys to please ask questions or please answer the questions that I ask you. So please feel free to join the OWASP Sydney channel. I think the message would be posted by Jack by now. So please check the message, join the channel, and please try to answer the questions. So threat modeling, going by definition, it's a process where we are trying to identify threats which could be potentially exploited using a vulnerability, or if there is no enough protection against a specific threat, the threats that can be identified can be enumerated, and we make sure that they get mitigated properly. In other words, what we are trying to do is we are trying to find a weakness and we are trying to fix it even before something gets pushed to the production. Ideally, you want to do a threat modeling before you push your code to production. However, if there is an instance where you haven't done threat modeling and something has been pushed to production, you still want to go ahead and try to identify various threats. What we are basically saying is we want to do a risk-based approach to security and keep this in our mind when we are doing threat modeling. What I mean to say is you need to know who is your attacker. You need to understand what an attacker can do by exploiting the system that you're developing. I'll give you a simple example. Let's say you are a small e-commerce website. You know PHP, you know MySQL, you have designed your small e-commerce website, and you're selling cool t-shirts. Great. Let's say you make 100,000 profit every month, which is great. You have a couple of employees. Sounds good, right? Now, if I were an attacker, or if you were designing that e-commerce website, you shouldn't probably be worrying about a nation state attacker hacking into NASA and exploiting the US government. Sure, that sounds cool as a news article, but that shouldn't be your problem. But what your problem should be is, because you are the owner of that e-commerce website, your problem should be, can someone inject a credit card skimmer onto my checkout page? Can someone log in without being authenticated onto the system and buy products on my e-commerce website for $1? Can someone spam my users and take away the business from my e-commerce website to their e-commerce website? What I mean to say is you need to know what you're protecting. You need to know how an attacker is attacking. You need to understand that you need to be slightly grounded, or you need to know your business case and then try to do threat modeling on the basis of that. So the three fundamentals of threat modeling are: one, we need to understand what are we protecting, who are we protecting from, and how are we protecting. These are the three fundamental questions that you want to keep in your mind every single time you are trying to design a threat model. Actually, if you ask me, it's not just about designing a threat model. These are the three fundamental questions that I try to ask in my day-to-day life about multiple things. The reason I say that is, unfortunately, human beings are absolutely terrible at identifying threats. Like we are bad, we are really bad. And unfortunately, our brains have been trained to think and not identify real threats. You guys don't believe me, right? You guys must be thinking, oh, like Abhijeth is like saying whatever crap. I'll ask you a question. How many of you here are scared of sharks? I can't see your hands, but I'm assuming if you go into a room full of people and ask how many of you are scared of sharks, most of them would be like, "Oh no, wow, I'm scared of shark." Yes. Now my second question is, how many of you are scared of mosquitoes? I mean, it's just a mosquito, right? Just a small insect. Like if a mosquito falls on you, you can slap it, it would die. Probably can't cause you any harm, right? Again, that's how we have been trained to think. But according to this famous news article, there are about 830,000 fatalities that are caused due to various mosquito bites. And just in 2016, there are about 445,000 people that have been killed due to malaria. That's an astonishing number, right? Now just think about it. Do you think so many people are getting killed because of a shark? I mean, ideally, for you to be killed by a shark, you need to live in Bondi Beach, you need to know how to swim, or you need to know how to surf, and you need to go on a Saturday evening when all the kids are in the water so that a shark can actually come and kill you. Bad example, but you know what I mean, right? So what I mean to say is, for someone to be attacked by a shark, there are so many factors that need to be validated. But for you to be affected by a mosquito, all you need is a small hole in the wall or through your window. And when you're sleeping, a dangerous mosquito can come and cause harm to you. But again, that's why we as human beings have been trained to not properly think about threats. Now, thinking about threats, there are various kinds of threat model methodologies that are available outside, right? Few of the most common ones are called like Stride, Pasta, security cards. Stride is one of the most commonly used one, where we will talk more about Stride. Stride will be one of the famous threat models that we will be doing today. I recently came across this article which talks about the different threat modeling methodologies that are available. I will highly recommend you guys to spend about 7 to 10 minutes and please read this article. Um, Shout out to the author. I think the author is a professor at Carnegie Mellon University. Absolutely one of the best articles that I have personally read about threat modeling. So as I mentioned, in today's session, we're going to talk about Stride, right? Stride basically classifies the entire threat model into these multiple categories. For example, spoofing. When we are talking about spoofing, basically the threat that you're trying to measure is like, can someone spoof this information? What's the mitigation for spoofing? You want to make sure whether his user is authenticated. So you want to make sure the desired mitigation is authenticity. Tampering. Now, can someone tamper with the information that that the asset is trying to protect? For that, you want to look at integrity. Integrity is your desired mitigation. Reputation, you want to make sure that your information is non-reputable. Information disclosure, confidentiality, denial of service, these are basic definitions. I don't want to go deeper into it, but these are the fundamentals on which Stride model is built on. Now, Ideally, the steps that involve in a stride model are the first step is you want to go through the data flow diagrams, or you want to go through the architecture diagrams, kind of understand what's the user, who is the asset, and step one, step two. For example, what happens when you type www.google.com in your browser? Step one, there's a user. Step two, they open a browser. Step three, they type www.google.com. Step four, so basically you want to classify and write down your data flow diagrams. The second one is identifying the threats. Now, if you remember, I showed you a sample example of web architecture. This is also an example of a simple data flow diagram. Now, what you want to do is you want to identify threats on multiple instances and list them down. So once you do that, the third thing that you need to do, you need to understand what are the mitigations already in place. Now, sometimes depending on how mature your company is, sometimes there'll already be some mitigations in place, sometimes there wouldn't be. So you want to understand and list down what are the different mitigations that are in place. The fourth thing, if I tell you, like for example, if I tell you that, okay, this application has authentication, you as a by default, as a threat model designer, you shouldn't trust me, right? Like, because that's one of the fundamental things that we shouldn't do. So what you need to do is you need to actually go and validate whether the mitigation is actually in place. Now, who does threat modeling? Generally, security architects, engineers, pen testers, or security champions. But if you're a matured company, or if you want to be matured, you actually want your engineering managers and engineers also understand threat modeling. The concept is very simple, right? If everyone can think like an attacker and come up with threats, they wouldn't introduce a vulnerability in the first place. So in an ideal case scenario, I think everyone in a company needs to be doing threat modeling, or at least need to think about various threats that they would be introducing. And this is also a simple mapping I found. Actually, one of my close mates sent this to me, where you can classify stride based on CWE and OWASP top 10. And because these are the different categories, what you want to do is like you want to put these into like different categories, and these are the different classes of vulnerabilities. For example, if the threat that you identify is with tampering, the potential vulnerability is an injection class of vulnerability, or a process scripting, or an XXC. Or if you say the threat is information disclosure, then the kind of vulnerability is an insecure direct object reference, security misconfiguration, or stuff like that. Enough of all the theory that I've been teaching you with. So what we will do now is this is where I will request you to start typing answers. So I will give you a use case. So the first use case that we're going to talk about today is one of the most common things that we all know are ATM machines. So let's say you as a attacker, or you as a bad actor, you actually want to hack into an ATM machine. I would request you to please give me, again, please don't do it in the real world, but if you are an attacker, I want you to give me all the different ideas that you can think of to hack into an ATM machine. I will be looking at the chat, so please feel free to share those messages. And as you tell me the different ideologies or like different techniques, I'm going to list them down here. So first thing, I'd call it ID. 1, 2, 3, 4, 5. So feel free to join and share the message, or share the idea, or share the threat.
So we've just had one from developer Steve in the Discord chat, and he has said skimmers and said that might not really be an attack though.
Yeah, so what we're trying to understand is like how skimmers is a good thing, but is it really a threat? But for the sake of argument, let's write skimmers, right? Sure, skimmers. And we will have a description of it.
We've got Mark on YouTube that has said, take money out using someone else's card.
Yeah, steal someone's card. That's a good idea. Well, don't do it in real life, but yeah. Any other threats?
Got a few people typing at the moment.
Give you guys 30 seconds. 60
Yunsa has
seconds.
said, socially
Bomb it.
engineer someone into giving cardless cash code.
Social engineer. Yep, that's definitely a valid threat.
You can bomb it. There's a lot of ATM bombings.
Absolutely. ATM bombing is actually one of the most common attack scenarios. One more.
Physically breaking the machine as well.
You guys, look, I'm not strong enough, but if you guys are strong enough to physically break an ATM machine, good luck. So that's good. There are 5 different ideas. So what you want to basically do is write a small description, use it somehow, install a skimmer to steal other ATM card details. Maybe that's the description or the scenario. Steal someone's card. I don't know, punch them and take card. Don't do it. But let's say that's the threat. Social engineering, really valid threat, right? You could go to someone who's trying to withdraw money and say, can I help you? Or maybe I can help you. And what they could do, the scenario is they're inserting their credit card or debit card, and you ask them to insert the PIN. And while they're typing the PIN, you look at the PIN, right? So you're social engineering and stealing their debit card PIN. So this is a valid attack. Like this is one of the most common things that happens at like most of the ATM machines actually. So social engineering, description, ATM PIN, writing a simple example, ATM bombing. So again, this is actually one of the most common attacks, as I mentioned earlier. Let's say for the sake of argument, an attacker has some tools using which or some kind of software that will help them to like fuzz and then basically break into the card details and like find more. And physically break ATM is physically break ATM, right? Break it. Now, according to Stride model, what you want to do is now that you have identified few threats, you want to specify Stride. Now I will go back to the definitions of Stride, which is this. And what you want to do is you want to put these into categories. Like for example, stealing someone's ATM details by skimmer probably falls under. Feel free to type your answers and I'll have a look at the answers. But stealing, spoofing, is it really spoofing? Because like it's not really spoofing. It's definitely tampering, because at that point the user will lose trust on the ATM machine, right? So tampering, you would like write down T. Repudiation, probably not. Information disclosure, absolutely, right? Because it's a valid threat. There's a skimmer that's stealing someone else's credit card details. Denial of service, maybe, maybe not. So if you steal someone else's debit card, maybe you will block it, or maybe something happens. So maybe, but for the sake of argument, I'm also going to do T. Elevation of privilege. Now, if you steal someone's credit card, obviously you can steal the information. So I think E is also valid. So what you are trying to do is you are now thinking like an attacker and thinking about various use cases or various threats. And then you are identifying what are the various threats and then putting them into categories. For example, I'm going to do an ID, E, and let's say this one has tried. Now, this is when I would like you to stop thinking like an attacker. Now, imagine if you were manufacturing this ATM machine, right? And I am a security engineer, and I come to you with these 5 threats. The first thing that you want to do is you want to do a simple risk ranking. And out of all these 5 different threats that are identified, what you would like to do is, for the sake of argument, you want to identify your top 3 threats. Let's say you don't have resources, you can't fix all these 5 threats, you want to identify top 3, right? So what you would do is, based on various risk ranking metrics like CVSS, or if it's a web-based application, OWASP risk ranker, you will risk rank these threats. What is the threat of someone installing a credit card skimmer? I think that is high. Punch them and take the card? Probably low, because there's cameras and sometimes there's security guards. Social engineering, I would say medium. Attacker has some tools, ATM bombing, I would say high. Physically break it, I would say low, because most of the new ATM machines are quite strong enough. And the next step, or one of the final steps that you need to do, is you want to understand what is the mitigation that is already in place, or what is the mitigation. So there are 2 things, right? I like to do 2 things. One is mitigation in place, mitigation recommended. For example, how can you as an ATM machine stop from an attacker installing a credit card skimmer, right? So the mitigation, for example, is like, I don't know, keep the ATM slot thin enough, or make sure, okay, that's the mitigation in place, right? So let's say now the ATM manufacturer is like, okay, this is very thin and you can't inject something else. So if there's a customer, you can identify it immediately. But you have to recommend a mitigation. The mitigation that you probably would recommend is like, have some detection. Again, just writing down as an example, you would say, this is the mitigation I would recommend. You have to make sure there's some kind of detection, so that if someone immediately puts like a credit card skimmer, you would immediately come to know. And another example, social engineering. The mitigation that is in place is like, we train users not to share ATM pin, right? That's good. But you know what's a better mitigation? Multi-factor authentication. What if you enable multi-factor authentication? What if you want to make like a huge transaction, you need to enable multi-factor authentication? For the sake of argument, that's the mitigation you're recommending. So in short, and then the last thing that you need to do, obviously, is like validation. Once you recommend these things, once an engineer goes ahead and implements those things, you will then go ahead and make sure these mitigations are in place. So you will validate the mitigations that you have already mentioned. So in short, in the last 5 to 10 minutes, what we have basically done is a very simple version of Stride threat model. Nothing fancy, right? As I mentioned earlier, we can draw a data flow diagram. We can also make a complex, or like actually a real threat model. But this is the simplest version of a threat model, or this is like a fast track version of how you can quickly identify threats and then list them down and write down the mitigations. Now, let's for a moment assume you all are not security people. Imagine you're engineers, imagine you're product managers, imagine you're engineering managers, and you're standing there in your daily stand-up, or you're standing there in your Scrum meeting, and you're thinking, or you're brainstorming about a new feature. How amazing would it be if an engineer is able to think about a few of these threat vectors and actually write a mitigation even before they come to you to do a threat modeling? That is absolutely amazing, right? And that's the dream state that you as an organization, or you as a security team, would like to go. What I mean to say is that is when you actually make security as everyone's responsibility. And that is when you as a company are doing the right way of threat modeling, if you ask me. But that's a hard thing to achieve. And that's why you have the security champion program. You teach them about vulnerabilities, you teach them about various threats. You are basically enabling someone to think like an attacker. I personally believe one of the strongest traits for anyone working in cybersecurity is the ability to think like an attacker, the ability to do problem solving. And most of the time, what we are trying to do is we are trying to find fail case scenarios. What do I mean by fail case scenarios? How can I make the application not to work the way it is working right now? Or how can I submit something to the application so that it breaks? And I feel like that's one of the best ways by which you can start learning cybersecurity, or by which you can start teaching cybersecurity. So yeah, teaching someone the attacker methodology will make sure they're already thinking about various threats and they're mitigating threats even before they're getting introduced. Um, this is another use case. This is slightly technical. Now, this is the other example I wanted to give you, and this kind of goes to the crux of today's presentation. Let's say the use case now, we move on from the ATM machine. The use case is there is there is a support person that is working on a Google sheet like this, and it contains PII data. Every month, they copy the PII data onto a USB and go to a printer, put the USB drive and take a printout. Let's say that's the use case. Now, if you understand the difference between you withdrawing something from the ATM involves one major asset, multiple microservices or like multiple information assets, and then one user. Whereas in this specific scenario, there are multiple assets. Your computer is asset number one. Your USB is asset number two. Your printer is asset number three. And what is being printed afterwards is asset number four. And there's only one user. And if you think about it, if you're trying to apply a stride model, what you would like to think is like, what is the document that contains PII information? Can someone tamper it? Oh, if they want to, if they have to tamper it, they need to bypass, they need to find a way to inject it. Can they inject something into the into the PII? No, they can't. How can they not? What's the protection that you need to have? You need to have data integrity. Now, how is a user or a support person making sure the data integrity is achieved? What I mean to say is when you start thinking of stride model, it starts getting slightly complex. So funny enough, right? Um, I actually saw this on LinkedIn 2 days before. What I mean to say is like I posted on my LinkedIn saying, hey guys, there's a session, and automatically one of my mates, he said he was working on this threat model. And I asked him, he said he did not use stride. If you remember, I told you there are multiple ways, right? I asked him why he did not use stride or pasta, which are like the most commonly used. And this was his response. He's like, hey, it has its own benefits of using stride and pasta. But the reason he used NIST technique is NIST way of doing data modeling is very data centric. And by using a data-centric approach, instead of using stride model, you're actually relying on multiple data sets, and based on the data sets, you're identifying the different threat models. And the threat model that he designed, this is actually the threat model that he designed. I have a link. You can go back and have a look. What he has basically done is like he has taken the case study, he has defined them as like multiple points of interest, and based on that, I'm really sorry. I think the text is slightly unclear, but based on that, there are different attack vectors. The different attack vectors are identified, and for various attack vectors, there are various mitigations that are listed down. This is different from stride model, but the methodology is still the same. You want to identify, you want to think like an attacker, you want to identify what are the different attack vectors or threat vectors, and you want to identify what are the different mitigations. So the fundamental concepts of uh, the fundamental concepts of stride, which is like threat identification, mitigations, and validation, is kind of the same for like most of the threat modeling methodologies, but the way you do it is slightly different. I know most of you are wondering, hey, are there any tools that can help me to threat models easily? These two are my favorite, Microsoft STO and Threat Dragon. Threat Dragon is actually an OWASP project. I have listed their links. Feel free to go home, try them out, and then make sure you are able to understand. Like once you start working on them, you will have a better understanding of how to design your own threat models. The question is, do you already threat model? Now, if this was a live audience, I would ask how many of you do threat modeling on a day-to-day basis or for every pen test, or how many organizations actually do threat modeling. And the number is astronomically low. So my personal recommendation is like, try doing threat modeling, right? Like it's an absolutely amazing way. And even as a pen tester, if you're doing a threat model on any pen test project that you're doing, you would actually be able to connect the dots. Basically, what we are trying to do is you're trying to understand the use case. You are trying to understand the scope of what you're trying to achieve. You're trying to understand what is an application trying to achieve. And then you want to understand who is the asset, or like who is the attacker, who's going to use the asset, what am I protecting, how does someone get access to it. So by understanding the who's, what's, and how's about an application, you can then start thinking like an attacker. If you remember, if you would have observed me in the last 36, 37 minutes, I have said thinking like an attacker probably 10 times. And I think that is the whole crux of threat modeling. And then, yes, you by thinking like an attacker, you identify threat vectors, you compartmentalize various things, and then you find out the mitigations, and then you would basically come up with a diagram, or sometimes come up with a simple table, strike table. The most important thing, again, about threat modeling is ask questions and collaborate. If you are someone who likes to not ask questions or not discuss about threat modeling, you're probably missing out on a couple of threats. What I've always enjoyed doing is discussing my threat models with my team members. Or like once I design a threat model, or like once I'm listing down various, or if I'm doing an architecture review, I always like to ask a lot of questions to the engineers. Because engineers, by default, they make assumptions. And we as security people, our fundamental is like breaking those assumptions, right? So that's why I think collaboration is like super duper important. And what it also does is like it teaches the other person to start thinking like an attacker and identify threats. Now, for the last 42 minutes, I have been talking about various threat models, and we have done a very simple, small exercise. Again, very basic exercise of how to do a threat model on a non-technical scenario. I promised Rick just in the morning today, saying I have a little surprise for everyone who is joining this session now, or anyone who's going to watch this session. I have a challenge for you guys. If you have never done a threat model, or if you have already done a threat model, that's completely cool. What I would request you is, this is the use case. The use case is, let's say I am an architect and I tell you that I'm designing a website where there is a profile page. On the profile page, there is this functionality which allows a user to upload an image, and will validate the image. And if it's a valid image, I will allow them to put that as their profile picture. That is the use case. I will request you to go home, do your own research, identify your best threat model. Like I said, there are multiple methodologies. Pick a tool, or even if you don't use a tool, if you're using XO, that's completely fine. The deadline is 7 p.m. on the 25th of May. That is 1 week from now. Please make a LinkedIn or a Twitter post tagging me or tagging OWASP Sydney with a hashtag called sharing is caring. It doesn't have to be perfect, right? The whole point I want you guys to do this exercise is, it would be amazing if you can practice it. And also, I want you to start collaborating with other people. Quite often, people post their threat models on the internet and ask for opinions. And it's absolutely an amazing way by which you can collaborate and identify or think about threats that you haven't thought about. If you do it, the best threat model, or if there's one, there'll be one, but like the best threat model, or someone who has done a lot of research, I promise you from my personal expenses that I will buy any course on that website, and will get you like a 1 month subscription to the course, right? It's a pretty okay-ish website. Like it's it's a new company that is trying to launch various courses. It's called Offensive Labs. I believe they're also like a sponsor for OWASP Sydney. But if you click on Explore Courses, if you post a threat model and post it on any of your social media and ask for opinions, the best threat model, well, like I'll make sure that you get access to one of these courses that you wish to. So yeah, the whole concept is maybe you should start doing threat modeling, and I would highly request you guys to go ahead and start doing threat modeling. And I know for you to do your first threat model, you need a lot of resources. These are the resources that you need. If you're already able to think like an attacker, if you're able to think different, and once you start thinking, keeping that attacker ideology in your mind and start using these resources that are available, you should be able to design your first threat model. Thanks a lot for attending. Once again, I would really like to thank OWASP Sydney for allowing me to share my opinions. As you can see, I'm quite passionate about threat modeling. I do believe security is everyone's responsibility, and the ability to think like attacker actually makes any company secure, and it just improves the whole ecosystem irrespective of how you're contributing towards a company. And obviously, I would like to thank all the memes that I've used. I've not used a lot, but all the meme makers, all the contributors of the slides. And I would like to personally try and thank Jinish and Chintan, who have given me some information that I have shared in today's presentation. And the reason I included other people in today's presentation is one thing I believe in is like there is no exactly correct way of doing threat modeling. As long as you're identifying a lot of threats, you're kind of doing your job. As many threats as possible, you're kind of doing your job. And I just wanted to get a couple of my other friends' perspective on their view of threat modeling, and that's why I've included them. I do know that there's another Melbourne-based startup actually. Sorry, this will be the last thing I'll tell you, but I think docs.inspector it's called. Yeah, it's actually a Melbourne-based startup who is working on automating threat modeling in your application or like in your CI/CD pipeline. So go ahead, have a look at this, check this out. I think they also have like a GitHub project. If you like them, maybe give them a shout out, or maybe feel free to have a chat to them. But yeah, thanks for joining today's session. I guess now is a good time for us to have a discussion. I wouldn't say ask questions. Let's have a discussion and see how things go.
Well, I would like to say thank you very much, Javi. That was a fantastic presentation. Usually threat modeling put me to sleep. I think actually I was paying attention the whole way through. And yeah, thank you. That's really good. So let's give him a clap. He deserves it. Well done.
Yeah, it's one of those topics, right? Because it's not cool. It's not like I'm showing people how to find vulnerabilities, which I think is cool. But at the same time, it's also nice to know these things. And this is where there is a progression where you start becoming an architect, or when you start thinking like security designers or security architects. So yeah. If you have any questions, please feel free to ask.
I just would like to say we're gonna stop the recording here. We don't know if we're gonna publish it or no. It's gonna have to be reviewed, of course. But if anyone wants to join the conversation, please join Discord. The instructions how to join are on the YouTube channel. But we're just gonna be here talking and chatting. So if you guys want to join with Avi and us and have a nice chat just for a few more minutes, please just join us on Discord. So yeah, so join us on Discord. Join us on Discord.
Hope everyone's staying safe because of COVID. So thank you.